Okay, chemistry students, here we are with lesson 7.5. So we're going to discuss percent composition. So the first objective, is to calculate the percent composition by mass if you're given the masses of the elements in a compound and you know the original starting mass of the compound. Then the other way to do it is to calculate the percent composition by mass given the formula or the name of the compound and you figure out the formula. So the first method is kind of an experimental result method where you take experimental results and determine percent composition. And the second one would be more of a theoretical, knowing the formula of a compound, predict what the percent by mass of the elements in the compound is. So we'll give you lots of examples. Let's get started.
Alright, the percent composition, the definition of this is the proportion of an element present in a compound.
So mathematically, you're all familiar with percentages, but you would take the mass of the element in the compound divided by the total mass of the compound, and then you multiply by 100 to make it the decimal into a percent.
Alright, and the first example we have here is actually an experimental determination. To do these, they usually take an element and then they burn it to figure out what the masses of each element present are. And in this case, we're burning ammonia, 50 grams of it, and we're finding that we have 41.0 grams of nitrogen and 9 grams of hydrogen come off after the burn. So they want to know what's the percent composition of ammonia. So you have to do each part. First, we're going to take nitrogen, and well, to find the molar mass first of ammonia, I suppose.
Well, actually, when it's an experimental data like this, we don't need the molar mass. We're just because we're working with the 50-gram sample.
So we take the given number, which is 41 grams of nitrogen, and we divide it by the original, which is the 50.0 grams, each of which having 3 sig figs, and we find that it is 82.0% nitrogen. Now you can go on and do the math for the next one, which is 9 grams of hydrogen divided by 50 grams total. Or you could, be smart about it and subtract 100 minus 82 to get the percent. But right now we're going to show you the math because the math never fails. So this would be 18%, 18.0%. Oh, actually no, this one would just be 18%, sorry.
Because the hydrogen only had 2 sig figs.
Exactly.
So, okay, so we'll rewrite that as just 18, no decimal point. But Mr. Hunter's absolutely correct. If you know you got the first percentage right, you can just subtract from 100 to find the second one, or you can do the math the way that I've shown. Either way should get you to the same place.
All right, next example.
So now in this type of problem, you're not given any lab results. You're simply given the name of the compound or its chemical formula, and so you're asked to find the theoretical percent composition of the compound in the same method that we just did. So, here's an example problem. What's the percent composition of lead to chloride?
All right, so the first step in this, if you notice, we don't give you the chemical formula, so you have to be able to find the formula yourself. So lead 2 would be Pb2+. Chloride is, of course, Cl-1. So it would be PbCl2 is what we're actually looking at. And then you can actually start the problem by figuring out the molar mass of lead chloride, or lead 2 chloride. The molar mass turns out to be 278.
278.10 grams per mole. Now, one thing you will notice, I didn't mention this in the last one, I don't write units a lot of the time when I'm doing this because since you're always dividing a mass by a mass or a molar mass by a molar mass, they cancel out and it's a unitless quantity, so I just let them off from the get-go.
Which is fine. All right, so then we have percent lead. For that, we have to know the molar mass of just lead, which you just looked up to figure out the molar mass of lead chloride.
That was 207.20. That's right off the periodic table.
And you divide it by the entire mass, which is 278.10. And times it by 100. And you find out that in this compound, lead is 74.5% of the
by mass.
By mass. And then, of course, chlorine, you can do it one of two ways. You do the math, where you take 35.45 times 2, which is the total number of mass of chloride, and then divide it by the entire mass of lead chloride. Of course, multiply by 100, and you find out it's 25.5% by mass chlorine.
And we could also have just taken 100
Subtract 74.
minus 74.5, and we're going to get to the same place.
Yes. But if you're not comfortable with that, you have multiple avenues for getting to the same place. All right, another example here, we want to determine the percent composition of aluminum hydroxide. So once again, we have to know how to, get from the name to the formula. So it's aluminum, which we know is 3+, and hydroxide, which is OH minus 1. So it turns out to be AlOH3. Again, the next step is to figure out the molar mass. So for this, the molar mass is 83.98 grams per mole.
And then we just hit the periodic table,
Yep,
find the
so
percentage of each component there.
Aluminum would be 26.98.
26.98
divided by 83.98.
divided by.
Might run out of room on this one. And you hit the enter sign with times 100, and it turns out to be 31.12% by mass aluminum. And then you have to do at least one more this way because there are 3 elements now. So percent oxygen would be 3 times 16.
Why the 3, Mr. Hunt?
That subscript outside of OH would tell us that we have 3 OHs, so that way we have 3 O's.
Okay, so right up here, we have to multiply that through. 3 O's, got it.
And then divide it by, again, 83.98.
I didn't manage my space very well in this one.
That's fine. You hit enter, and you find out that by mass, it's 57.16%. And since we ran out of space, we're just going to give the answer for percent by hydrogen. You can do it one of 2 ways, of course. Again, you can do the math, or you could add those 2 other percents together and subtract it from 100. And you'll find by mass, hydrogen is only 3.57%. And that is common.
Even though it has as many atoms in there as the oxygen, it's much lower percentage.
Yeah. You'll find this is a common theme for hydrogen, only take up a few percent by mass. All right, the last one here is butane.
Oh no, a hydrocarbon.
Yep, so we hit all the naming, I think, except for organic, to be honest. Well, not organic, I mean covalent. So butane, meth, eth, prop, bute, so it's C4, and it's an ane, so it's 2N plus 2 number of hydrogens.
4 plus 2 would be 10.
And the molecular weight, or molar mass, of this compound would be 58.00, because we rounded.
And that was just 4 carbons plus 10
Yep, so it'd be 58. Hydrogens. So then we take the percent carbon, which is 48, divided by 58.
48 would be 12 times 4.
Yep.
Divided by 58.00.
And we find your answer to be 82.76%.
We'll keep our sig figs.
Well, remember, these are all given values anyway.
82.76.
So in the case of given values, sig figs aren't all that important. But just we always try to keep the
maintain the
same level of. Right. And percent hydrogen would be, you just subtract the 2 from each other if you want. 100 minus 82.76. And this is one of the higher percentages of hydrogen we'll usually get. This is 17.24% hydrogen, which is a little bit higher than normal. But again, it's a case-per-case scenario.
So again, we're taking something everybody's already familiar with, percentages, applying it to a compound, and we can figure out the percent by mass, either from the experimental data or from the formula.
Exactly. All right, again, if you don't know how to name yet, please come in and you can help naming, because you noticed you couldn't do this one bit without being able to name. So good luck and good night.
Okay, students, so we have 2 post-video questions for you, one of each kind of percent composition problem. So the first one, we're going to use some laboratory data. So you have a 16-gram sample of methane, and it's composed of 12 grams carbon and 4.0 grams of hydrogen. Determine the percent composition of each element. All right, second one, we're going to use the chemical formula to determine the theoretical percent composition for the compound ammonium chloride. So give those a try, and we will discuss them next time. Until then.